Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is Lesson 6, Drawing Geometric Shapes. This classwork says that there's an exploratory challenge. Use a ruler, protractor, and compass to complete the following problems. Use your ruler to draw 3 segments of the following lengths, 4 centimeters, 7.2 centimeters, and 12.8 centimeters. I will do the 4 centimeter one with black ink, and I'm going to move my ruler down here, and I am going to extend it out, and I need at least 4 centimeters, and there it is. So I take my ruler and I start at the 0 mark, and I draw until it stops at 4. I move my ruler and I label it 4 centimeters. I'm going to do the next one with red. So I bring my ruler down. I need to make this one 7.2 centimeters. So I need a little bit more ruler. So if I drag this out past 7, there we go. And then if I start right at the 0 and draw all the way over to 7, okay, and then move the ruler and label that. Oh, 7.2, my fault. Let me put it back. So let me erase that. Forgot the 0.2. So let's try it again. Start at 0, go to 7, and then 2 more, which would be millimeters. So right about there. Okay. 7.2 centimeters. And then finally, we're going to do one that is 12.8 centimeters long. So I bring my ruler, and I need more rulers. So that's what's cool about this one. And it doesn't matter where you put it, as long as you have room to put it there. So I'm going to start at 0, go all the way out to 12.8. Okay, let me try that again. I ran out of board here. I had to move my pen. So let's try that again. 12.5678. That one was 13, so if I get my eraser and just erase back to 12.8, which is right there. Okay, move that and label it 12.8 centimeters. Okay, number 2 says to draw a complementary angle so that one angle is 35 degrees. So the first thing I'm going to do is identify the vocabulary. And complementary means that it's 2 angles that add up to 90 degrees. So if I want to draw an angle, the first thing I need is a straight line. So let me get my ruler here. And the length of it doesn't really matter. Okay, so I'm just going to draw a line segment. So I'm just going to draw this segment here. Move my ruler out of the way. So there's my line segment. Now if I want an angle that's 35 degrees, then I need to take my protractor. Okay, and put my protractor right on the end point of that, so that that line is right on the 0. And I want an angle that is 35 degrees. So 30 is here, and 5 more is right here. Okay, so there's the arc. So if I move this up, if I move this up, 35 degrees is right there. And that's where I put my mark. As you can see there. So that's 35 degrees. So once I find it with the protractor, then I bring my ruler over here. Now the nice thing about this ruler is it tells you the degree measure. So I'm going to cheat there and get it to 35 degrees. You would not have that opportunity with a ruler on a piece of paper. But I'm still showing the same procedure. So there is a 35 degree angle. So I'm going to label it 35 degrees. Okay. So in order for something to be complementary, it's some angle plus 35 degrees of the angle we have, and the 2 of them equal 90 degrees. So to find the other angle, I subtract 35 from 90, and I get that angle to equal 55 degrees. So I need a second angle that's 55 degrees. So there's two ways I can do this. I'm going to show both. I could either draw two angles next to each other like I'm going to do first. So my second angle, I just need a straight line. And then I need my protractor. I need to put it right on that vertex there. Right there. And I need to draw an angle that is 55 degrees. Well, 50 is here, 60 is here, halfway between is 55. It is right there. So after I mark it, move my protractor out of the way, move this, I'm going to cheat again, 55 degrees. You will not be able to do that on your paper. I'm just doing it for display purposes. Okay, so there's my angle that is 55 degrees right to that mark, and this is 55 degrees. Okay, that is one way to do it. So are the angles required to be adjacent, and that means sharing a side? And the answer is no. The other way I could have done it was I could have gone to my original angle, put it right on the vertex, like so, and drawn an angle that goes up to this 90-degree mark right here. And then when I do that, it will look like this. This is 55 degrees. The two right on time. Okay, the next example says to draw vertical angles. So I'm going to just get my ruler here. And I'm just going to draw any angle. It doesn't matter. I'm just going to draw a line segment for starters. So if I draw this segment like this, there's a straight line segment. It says draw vertical angle so that one angle is 125 degrees. So there's my line segment. If I bring my protractor down, and actually I need a point where they're going to intersect, and that'll be right there. And I put this right on that point, but I need to rotate it so that it is right on that line segment I just created. And I need 125 degrees. Keep forgetting to grab my pointer here. 125 degrees is right there. 125 degrees. It's saying 20, but it's actually 125 because the 20 degrees, it's not 20, it's 125. Right there, 125 degrees. So I need my other line to go to this point right here. So once I do that, when I take my ruler, rotate it, and line it up with my vertex and that point I just created. Okay, need to make this a little bit longer, move this down here. So now I'm lined up with that point I made for 125 degrees, and now I'm just going to draw a segment here. So those are two angles that are vertical, and this angle right here is 125 degrees. Since that's 125, so is this, because vertical angles are common. So it says label each angle formed with its measurement. Well, if this is 125 and the total of the straight line is 180 degrees, I want to find this angle here. I'd say x degrees plus 125 degrees equals 180 degrees. And I subtract 125 degrees from both sides. These cancel, and I get x equals 55 degrees. So this is 55 degrees, and this is 55 degrees. So there's our first three constructions. Okay, this question says to draw three distinct segments. Distinct meaning different. Okay, lengths 2, 4, and 6 centimeters. So if I get my ruler and bring it down, and I just want to draw a segment, and it's got to be 2 centimeters long. So I start at 0, go out to 2. Okay, I want to forward just a little. 2 is right there. Okay, so there's my 2 centimeter segment. I should always label it 2 cm. Okay, and then it says use your compass to draw 3 circles with the radius of the one of the drawn segments. So now I'm going to use my compass, and I am going to put that at one end of my segment, like so. I'm going to drag this out to the other end, and I'm going to rotate it 360 degrees. Okay. So there is my circle around the 2 centimeter segment. Now I'm going to draw a 4 centimeter segment. Now my circles are probably going to overlap because of I can make them really close though. So if I start right here and I go over to 4, my segment has to start here, and I want to go to 8 now to make it a distance. So that is, if you measure it, 4 centimeters. So then I'm going to label that 4 cm. And then I'm going to bring my compass over, put it right on one end, extend it over to the other end, and rotate it around. So there is a circle with 4 centimeters. Okay, and the next one I'm going to do is going to be 6 centimeters long. So I'm going to start at 6 and go to 12. Right there. Okay, so if I measure that from 0 to 6, that's 6. So that's 6 cm. I forgot to change my color, but that's okay. I'll make the circle blue. And when I put my compass here and I extend this out, I need to rotate it first. So I put my compass right on that end point, right there. Extend this out to here. I'm going to create a circle. Of a radius of 6. Okay. So there is 3 line segments that are distinct and 3 circles with that radius. So there they are. Number 5, draw 3 adjacent angles, A, B, and C, so that A is 25 degrees. So let's start with A. So I'm going to just draw a segment to start with my angle. So in order to draw angles, we need a protractor. So I'm going to get my protractor. Okay. And I'm going to put it right on the end right here so that lines up. And I need to make a 25-degree angle, which is 25, which is right here. And I'm going to draw a segment out to that. So if I bring my ruler up and put it right on that end point there and draw a segment, okay, that is 25 degrees. Okay, now it says B is going to be 90 degrees. So they are adjacent, so they're going to share sides. So I'm just going to continue with this. I'm going to bring my protractor up like so. Bring my screen back down so I can see where 90 is. I'm going to put a mark up here at 90. See how it's right at 90. Move my protractor. Line up my ruler with my vertex and my segment, or my point that I made with that protractor, and I don't need to go all the way up to that point. I just need to go to the vertex. So this is 90 degrees. Okay, and let me stop there because that is incorrect. Let me think about that again. I just realized what I have done. If we're going to make adjacent angles, and B has to be 90 degrees, it's not going to overlap or it's not adjacent. I need to rotate this, so this is my 0 line that I'm going to start with. And I need to make my 90-degree angle over here. So it's a 90-degree angle that will be adjacent to this 25-degree angle, which is like so. So now I'm going to bring this over 90 and 25. I'm going to cheat again, 115, just so these line up quickly. And I'm going to have my vertex and my line segment right here going up to this mark. And now that is a 90-degree angle. And these 2 angles are adjacent. Okay, so now we got 2 done. And the last one says C. So this was angle A. And this is angle B. And now I need an angle C over here. That is 50 degrees. Okay, so now I need to put my protractor right on the vertex again. Rotate it so that the 0 is right on that red line I made for the 90-degree angle. And I need to find 50 degrees. Okay. Now, let me make this smaller because I can't see where 50 is. All right, so now 50 is right here. Here's the 50, and so it's out here. So I made a little mark with that green there. I'm going to bring my ruler over and draw a segment that goes from my vertex to this green line here. Okay. This gets a little tricky with these electronics. First of all, that's in the way. Okay. Getting there, just real precise. Got to be precise. Okay, and right about there. So now if I draw a segment over to that line, then that angle there is C, and it is 50 degrees. Okay. So those are 3 adjacent angles, 25, 90, and a total, and 50 degrees. So their total would be 140 plus 25 is 165 degrees, all the way from the blue to the green is 165 degrees. Okay, number 6. Draw a rectangle ABCD. Okay, so now we're going to draw a rectangle. We rotate this around. We need a straight edge. So it says AB and CD are 8 centimeters long. So I'm going to put my mark here, and I'm going to go to 8. It's easier to go over a little and then erase. The eraser is more precise. Okay, so there's 8 centimeters. So I'm going to call that AB. So here's A, and here's B. CD is also 8. It's up here somewhere, but AD has to be drawn first, and it is 3 centimeters. So let me bring that back up so my eyes can read it. Rotate it around so that we are at 0 degrees. Put it right on the end point here with this line right on the green line. And I think I would want to make this a little smaller. And I want 90 degrees. That's what I'm doing with this. I want a 90-degree angle because rectangles have 4 right angles. Okay, so then once I do that, I rotate my ruler over, line it up with the end, and draw a, why is this not? Okay. All right, just 1 second, my ruler's failed. Okay, so I fixed my ruler, so now I start here and I draw a line up, just like that. But remember, it only has to be 3 centimeters long, or it only can be 3 centimeters long. And this is line segment AD, so I put my ruler right here at 0, and I'm going to get my eraser. I'm going to erase back to the 3 mark, which is right there. Okay, so now I'm going to rotate this back down. I'm going to draw a segment from here. Actually, let me do one more thing. I'm going to bring my protractor back in, put it right here on this end. I'm going to mark a 90-degree point right there, and bring my ruler up. And this time I will measure it 3 at the same time as drawing it. Trying to get it right on the end there. Start here, draw up to 3. Get my eraser, come back to 3 right there. And then all I need to do now, since I've already measured those 2 as being 3, if I bring my ruler here and just extend a segment from here over, it should be 8 as well. And we have 4 right angles. So this is 8cm. This is segment AD, that is 3 cm. And this is segment BC, which is also 3 centimeters. And segment CD is 8 centimeters. And we know that every angle in a rectangle is 90 there's our rectangle. Okay, number 7. Draw a segment AB that is 5 centimeters in length. Okay, so I'm going to draw a line segment AB. Get my ruler. 5 centimeters in length. So it's right there. My eraser, go back to 5. There, 5 centimeters in length. That's segment AB. A, B, 5, C, M. Draw a second segment that is longer than AB. Label one endpoint C. Okay, so I'm just going to do it over here. I'm going to make this one green. And I want it longer than 5, so there's 5, so I'll just go a little bit longer. That was about 7, okay? And it says label one endpoint C, so I'll call this C. Now what they want us to do is use a compass to find a point on your second segment, which will be labeled D, so that CD, this segment, equals this. Well, we already know that this is 5 centimeters, but this one's over, it's like 7. So in order to do this, we use a compass. We put the left end pointer on the left end, drag this out to B, so that it would be the radius of a circle if we were to draw one. So if I make a mark right there, oh, I moved it. I make a mark right here. Okay, that is a circle with a radius of 5 centimeters if I go all the way around. Okay, it's a circle with a radius of 5 centimeters. So if I move my compass over here, don't change its size, and put that right there, and repeat, but I don't need a whole circle, I'm just going to do an arc. That would be a circle if I did an entire circle. Actually, let me do it. Okay, let me bring this back over here. Right on that line. Okay. They're a little quirky sometimes. Okay, so right there. Move this down to C and make my arc. Put a point right here, or if I wished, I could take my eraser and erase it back to that point and call it D. That's what they're asking. So now AB was 5 centimeters and CD is 5 centimeters. Okay, number 8. Draw a segment AB with a length of your choice. Okay. Use your compass to construct 2 circles. A circle with the center at A and radius AB, and a circle at center B with radius ABA. Okay, so what they mean is draw a line segment any length. So I'll just do one that's, I don't know, 6 centimeters. 6 cm. Label that A. Label this B. It then says number 1 says a circle with center A. So the center, this is the pointer. Okay, and a radius AB. So that means to extend this out to the other end of the segment. That is going to be the radius of our circle. Instead, to draw a circle with that radius. So there it is. Okay. So I have this circle here. Center A, radius AB. It also says to do another circle with the center B, which means put this pointer on here and go over to the other side, A, and make a circle with a radius of BA. So when I draw this circle, then we get this. So this is segment AB. The red circle is a circle A, center A, radius AB, and the green circle is centered at B with a radius of BA. So this is a construction of 2 circles that are congruent, and they share the same radius. Okay, number 9. Draw a horizontal segment AB 12 centimeters in length. So I'm going to get my ruler. Down here, I need to draw a segment that is 12 centimeters long. So I'm going to start at 0 and go out to a little more than 12. Get my eraser, erase it back to exactly 12, and move my ruler. So now that's A. Draw a horizontal segment AB 12 centimeters in length. Done. Label a point 0 on AB that is 4 centimeters from B. So I need to label this AB. Here's A. Here's B. Now they want me to measure 4 centimeters. So if I put the 4 at the end, I want to count backwards to 0. And it would be a point right here. Okay. So that would be my point right there. So this is 4 cm from B to this point here, and label it O. Okay. Part B. Point O will be the vertex of angle COB. So C is somewhere around here because B goes this way. Okay. COB. I don't want to put it here. Okay. So this whole thing here is 12 cm. This piece from O to B is 4 centimeters. Now it says to draw a ray OC so that the ray is above AB, so I want it up here. And angle COB is 30 degrees. So I need to get my protractor, bring it down to O, put it right on O so that it's on the line, and I want to go over to 30 degrees, which is right here. Draw a line segment from O to that point and label it C. And this arc here is 30 degrees. So that's part B. And C. I'm on D. Draw a point P on AB that is 4 centimeters from A. Take that back down to 0. Put this at 0. Count over to 4. 4 is right here. So I'm going to put a point right there and get rid of this. I'm going to call that point P. And this is 4 cm. Okay, so that's D. E says point P will be the vertex of an angle QPO. So Q is somewhere in here. Draw PQ so the ray is above AB, and angle QPO is 30 degrees. So now I'm going to bring my protractor down, put it right at P, so it's lined up. 30 degrees is right over here. And so now I draw a line segment from P over 30 degrees to this point here, this direction. So label that Q, and this is also 30 degrees. Okay, so there we go. They just asked us to do a sketch, see if we could follow all those directions, and that was what they're asking. Number 10, draw a segment AB of length 4. So I want to rotate this down. Draw a segment AB length of 4. So I'm going to start here, go over to a little more than 4, get my eraser, and erase. All right, that's done. I'm going to label that 4 cm. And this is A, and this is B. So that's segment AB, 4 centimeters long. So this part's done. Then it says draw 2 circles out of the same size, one with center A and one with center B. Okay, so I need my compass. And I'm going to change the color to red. And so it wants us to draw 2 circles like we did before, one centered at A, one centered at B. That is the same length. How about out here? Draw a circle. Okay. this segment out to be right here and draw a circle that is the same. I'm not going to move it. I'm just going to do another circle that is the same diameter as the last. So those two diameters are the same. Those two circles are congruent. I didn't move the compass. Okay. With the radius of length A, with a radius of a length that allows the two circles to intersect in two distinct locations. So there's a point of intersection right here. There's a point of intersection right there. Label the points where the two circles intersect, C and D. So I'm going to call this C and this point D. Join AC with a segment. So now I need my ruler. And I'm going to try to get it as close as possible here. And there is a segment AC. Okay. Actually, that's not quite on, so let's move it. We need to rotate this a little more. Right there. Okay, so there's AC. Join AD with a segment. So now I want to bring this down here, and I want AD to be drawn. So if I draw a segment from D to A, so there's my segment. And then they want us to join BD, so we just keep doing this process. Okay, my ruler keeps doing this to me, so let me pause the video. Okay, so draw a segment from D to B is right here. And they also wanted us to join, I believe, B with C. Let's join B and C with the segment. So we're just going to keep joining these segments. Okay, that one I'm just going to move just a tad. I was off just a little. Okay, right there. Okay, so there's the four segments they're asking us. It says what kind of triangles are ABC and ABD? Okay, well, since the distance from here to here would be the same as the distance from here to here, these two sides are congruent. And these two sides are congruent. So this side is going to be the same for both. And these are both, they're not the same length though. So if I measure one of the blue ones, it is 5 centimeters. And if I measure this one, it's also 5 centimeters. So they're all 5. These are 2 are 5 and this one's 4. So a triangle that is 5 centimeters, 5 centimeters, and 4 centimeters, a triangle with 2 congruent sides but not a third congruent side is called an isosceles triangle. Okay, this number 11 says to determine all possible measures in the following triangle and use your tools to create a copy of it. Okay, so the first thing I would do is get my ruler. And this is not necessarily the only way to start it, but I'm going to start it by measuring this long side opposite the right angle, which is called the hypotenuse. And it is 5.5 plus 2 more, that is 57 millimeters, or 5.7 centimeters. Okay, so I'm going to redraw that over here. I'm going to draw it to 5, 6, or something like that, and erase it just to be more precise. I want to go back to this second mark right there. So there's 5.7 centimeters. Okay, so if I labeled this 5.7 centimeters, then this is 5.7 centimeters. In order to copy this, I will need my protractor. And if I put it right on this vertex, right here on that line, and I use my tool here to drag it up to here, okay, it's right about there, and that is a measure of 54 degrees. That's 54 degrees. So if I move this, I'm going to label this 54 degrees. This is 90 degrees, so I don't need to measure this. I'll explain that in a moment. And let me put this now here. And here's 54 again, and I put a mark out here. And then bring my compass in after I rotate it and draw a line segment from the end here up like that. Now, in order to figure out how far I would go, okay, I'm going to be more precise with this. I'm going to take my compass. I'm going to put it right on the end here, on the corner. I'm going to open it up. I'm going to rotate it. So it's right on this segment right here. I'm going to bring it out to this end right here. So if I drew a segment there, it's about right there, maybe in a little more. Approximately right there. So if I bring this down, put it right here on the vertex, I can find the same length by doing this here. So there's my vertex. So I just copied this segment here using my compass. Bring this over, rotate it. Okay, another way I could have done that is, I know this is a 90-degree angle, and 54 degrees plus 90 degrees plus x degrees equals 180 degrees, the sum of a triangle. And 54 plus 94 is 144 degrees, plus x equals 180 degrees. Subtract 144 degrees from both sides, and that will give me my other angle, which is 36 degrees. Okay, so I know this is 36 degrees. So I could have taken my compass, or my protractor, put it on this end, as close as I can get it possible. Right there is pretty good. And move this over to 36 degrees, which is right about here. There's 36. So if I put a mark over here at 36, move my protractor, bring this up, move it to 36 degrees, and line it up, it'll line up with both. So if I draw this segment here, then there is my 36 degree angle. There is my 54 degree angle. This is my right angle. And if I clean this up by erasing, okay, it would look like that. And then I just need to measure the other two sides. So if I bring this down, measure this side, it looks like 4.6 centimeters. Yours might be different in your book, by the way. Get that to 54, put that at 0, and that is 3.4 centimeters. Now keep in mind, this program doesn't project exactly the same as what was on your paper. If you do it on your paper, you should have gotten 3 centimeters. I'll write the values. This should have been 3 cm. This one should have been 4 cm. And this one should have been 5 cm. A typical 3, 4, 5 right triangle. And this is 54 and 36. So there you have it. And that is the end of lesson 6. Go do your problem set. Oh, by the way, smash the like.